Hello, all of you. So perfect that you joined the webinar today for airing. Today, the topic will be we're speaking about oil seals. So all the details about the oil seals, what is more or less like it's made out, how it's the description for these kind of oil seals, the definition. So it means like the norms, what kind of material do we use, what are the benefits, what are more or less like good to know, let's say something like this. And also, as we mentioned, oil seals with a spring and without a spring, and what is more or less like the latest technology, what you will find today inside in modern engines. So some words about me. I think some of you, oh, that was wrong. Some of you knows me. I'm Florian. I'm a technical trainer for airing. I was also the last 2 years with you for the annual meeting. So I'm happy to present you again the latest technology about oil seals. So let's jump in directly into the topic. Don't waste the time. So if we are speaking about oil seals, we're speaking about rubber material, or better known as elastomer material. And there exists a lot of different type of, I want to say, quality stages. So it means like if you see it here, we start with an NBR, then it goes up in the scale. That's also a reason why we have here an arrow which is going from left to the right. We're going with HNBR, EPDM, ACM, what is the silicon, FMQ, and then the best FPM, or the best elastomer material. So it means rubber material at all. It's FPM. So it means like if you see a description on a packing and it's named like FPM, that's the best, or FKM, depending a little bit in which area you are around. So this is a quite big important information. Why it's a difference between NBR and FPM? There's a difference between the material and also about the temperature resistance. So it means some application needs some higher temperature resistance material, requires something like that, but some of them it's not more or less like necessary to go for the best quality. Also, there's a price difference for sure. The point is also that it doesn't matter what kind of rubber material we speak, if this is also a valve cover gasket or oil pan gasket made out of rubber, we have a defined lifetime. The lifetime is depending about the softener in the material, and that took like 10 years until the softener is gone away completely. So that means like in this case, if it's getting too hot because the softener is gone, we have no sealing function anymore. The same is like with our oil seals. So valve steam seals, oil seals, any kind of rubber material, doesn't matter, has more or less like this average of 10 years lifetime. So that's very important to know. That's also the reason why you have to change oil seals from time to time. So, you know, I'm located in Germany, and Germany has for everything a kind of a regulation and the norm. And based on the norm, I have to give you a little bit the idea how you can see and how you can interpret some. Oh, now you see me nothing anymore. That's interesting. Wait a second. How can I do it? That's difficult, but here on the sticker, there's written down a code. The code is telling us, for example, like AWBS, OFLD, FPM. So what does this mean? So nobody knows it, because if you open up this packet, or if you open up, then you can see it. But I will explain to you what A, B, and what this kind of description means like. Quick and easy explained is like this. So we have, if we take a cutting draw about this oil seal, then you see we have a shoulder. The shoulder is defined like this, what you see here outside. And depending how the shoulder is made out of it, then we have a shoulder what we call B shape. So this is like the B shape, that is a raw metal material. Then exists also A shape. This is like with rubber coated. So it means like with an elastomer on top. This is what you see here. And then it exists a hybrid version. So it means both sides are available, A and B. That means like a little bit metal, a little bit rubber. So this is very important. So if you see on a description code that's named like AB, then you know there's a little bit metal, there's a little bit rubber. So general information, this B shape, you will not find this more or less like in automotive applications. So this is only used in industrial things. The reason is quite easy, because the fitting into a housing is close to be less gaps in between. This is pressed in. This is applications like gas, it's water, whatever. So what is very thin, what can best pass by. So we have applications what we want to seal against oil, what we want to seal against any dust. And there's quite good solution for it. It's metal, rubber, or only rubber, depending about the tolerances, what it is, and also the pressure, what it works on that kind of spot. So then it exists also the description S. The S is standing for a dust clip. In German, the S is for Staub, so it means starting with S, Staub. That's also the reason why we named this S. So this one dust clip, but it also exists two dust clips. So it means like what you see here, that's a double dust clip, more or less like as here. And then we have also a track lip. This is like what we have here, but this kind of design I will explain to you later. How the classical oil seal works, it's quite easy to explain, and there's also a cutted drawing view. What you see here, we have here an AB shape, so that's a real view, that's a little bit metal. There's outside the elastomer, what we're calling a rubber. We have one dust lip, and then we have here one contact point. You see this also as a yellow marked area. So here we have contact to the metal surface because we want to seal against a rotating metal surface. And to rotate off this metal surface, we have one contact point. And the contact point is defined on one spot. And in the back of this sealing lip, what you see here, we have a spring. So this is also a spring who is increasing the forces, the pressure about the sealing lip. So general information is like the sealing function, it's 80% done by the elastomer, so it means by the rubber. If this is getting old, the sealing function gets less and less. And only 20% by the spring, because mainly the guy thinks that the spring is doing all the job about the sealing, but that's not true. That's a rubber material. That's also the reason why if this is getting too old, then it's worn out, and so it's a need for to change the oil seal. There's also not the solution to cut the spring a little bit smaller and go tightening more around. So this is really not the solution what you're looking for. This is only for shortcut repair. So it means like it's not a long-lasting solution overall. That means also, if you understand the sealing function, what I will explain to you now, then you see this is not the right way to more or less like adjust a little bit the spring pressure in the back. Because how is this working? It's quite easy to explain, because you have to imagine if you have a rubber material and we have a metal surface. If you're moving the rubber over the metal surface, this is not more or less like smooth enough that it's working without any frictions and without any frictions at all. That's right the point. So in this case, we need a kind of a lubrication in between the rubber material and the metal material. So that means like in between, we need a liquid, any kind of stuff. And this is what we're using, is the oil from inside for using the lubrication function between rubber and metal to avoid any frictions, to avoid any burning marks, heat, whatever what it exists if you rubbering metal against rubber. So this is like here in between of our contact point of the sealing lip against the shaft. We have here an oil film who makes more or less like the lubrication. So what is the high risk? That some of this oil is going here in front outside and makes more or less like a leakage. So this is what we don't want to have. In this case, there's a clever function here inside in this oil seal, what calls a twist. So the twist here outside on this flank is creating, by the rotation of the shaft, some vacuum effect. So it means like it sucks the oil back into the oil sump where it should be and avoid any kind of leaking outside. So how the twist is looking like, I will show you now with the next slides. So if you take a look here, this is like how a twist looks like, and the twist is located outside of the flank. So it means like here where we have only contact by air, here's our oil side, and depending in which direction the shaft is running, it's creating this vacuum effect and sucks the oil back into the area where it should be. So depending on the rotating of your shaft, in which kind of direction it's rotating your shaft, you also need a right fitting twist. And the right fitting twist is marked by the rotation side. So it means like LD stands for left hand twist, then RD stands for right hand twist, and WD stays for alternative twist. How you can find out which is the right one, it's quite easy. You have to take a look on your shaft, take a look in which direction it's running, and in that direction who is running, this is the twist we are looking for. So it's going to the right side, then you need the right hand twist. If it's going to the left side, you need a left hand twist, and if it's going in both direction like an axle, then you need an alternative twist. That's quite important. Also, what you see here, there is also oil necessary. So why it's oil necessary? Because if you do not allow application in the beginning, if you install this kind of ring, then it's creating more or less like any kind of issues, what calls like frictions against the metal and the rubber. So in this case, some examples out of it, what could be happen? It's like that you have this sticky effect, some slipstick effects, what means like we have the metal shaft is starting with turning. We have no lubrication in between. So the rubber gets heated up. It sticks to the metal and destroyed your new oil seal. This is something what you really should avoid. In this case, for classical oil seal, also known as simmering, you need lubrication. So this is really a thin motor oil is the right one. Why thin? I will show to you later. So this is necessary, essential for the beginning if you install a new oil seal. So also the point, what will happen all the time with the oil seal is like if you check the shaft where the old oil seal was working on it, you have there some grooves, and the grooves is natural that they build up because the material is getting harder and then it's pushing the metal to the right and to the left side. It's not abrasive, so it's not going in a kind of a dust way away. So it's more or less like pushing metal to the left and to the right side. And so if you install a new ring on the same spot, it's get difficult because the diameter of the shaft is getting smaller. So in this case, you should avoid to put this directly on the same spot. In this case, it's recommended to put the oil seal more inside or more outside. Sometimes this is not possible because it's fixed inside in a housing, in a case, whatever, in a defined position. So in this case, there's also some point what we can recommend you, and this is like a repair sleeve. So this repair sleeves is like a very, very thin metal sheet, what you put over the shaft, put it directly on the spot where the oil seal normally was running, and then you install the same size of oil seal directly on this new surface. And this is the benefit that you have not to go for a different kind of size of oil seal, and you can also reuse the shaft by this repair sleeves. I know you're engine rebuilders, you're experts. This is maybe not the way what you prefer, but this is a clever solution what works out really in a daily base. Who is providing some stuff like this? This is for sure is the MSI. They're offering some good stuffs like this. Also SKF also offering this because they're also speedy sleeves and they have sleeves, protection sleeves, what calls MSI for it. So it exists in any kind of dimensions. That's also very important to mention because you can go for the MSI. They have a clever tool on their webpage, and you can type in there the dimensions what you are looking for the repair sleeves. Depending about your need of your shaft, then you can say, okay, what is the inner diameter, outside diameter, and the width of the shaft. So all of these data you put inside there, and then you get some recommendations. Okay, which is the right one, which is fitting to you, and based on this number, then you will find the right matching one, which is fitting exactly to your needs. The installation is quite easy. You put this over the shaft. There's also an additional tool with them, and then you can put this into the end position. And more or less like the job is done. So this is the only thing. What you can also do is like removing this outside metal thing with a side cutter, the flank more or less like to remove that. And then more or less the job is done. There's no waiting time. And as I told you, it is like that you can reuse the same diameter of oil seal directly also with this additional repair sleeve. So now we're coming to the installation of a classical oil seal. It's quite easy and understandable and I think all of you did this sometimes before. So it means like you have to check the shaft. This is in really good conditions, no dirt, no scratches, no defects are visible to see. It's all the time recommended to use some protection tools to avoid any damages for the new oil seal. You put your oil seal over the shaft into the right spot. Use some lubrication, so it means a thin motor oil. That is the right lubrication for this kind of application. And then, yeah, press your oil seal equal into the housing. So if you have a tool, that's recommended. There's also different kind of possibilities available, and then check if it's equal inside in the housing where it should be. So this is really like the classical thing. I think that's nothing special, nothing new for you. Why you should not use anything else like oil for the lubrication on the oil seal? It's quite easy. If you use, for example, a grease, then it's getting sticky. And if you have a stickiness outside of your flank, then you will cover it up maybe by dirt, by whatever what is flying around. This twist what we have here. So, and you don't want to cover up because otherwise this vacuum effect doesn't work out as it should be. So that is the thing what you should avoid. Use a thin motor oil, use any kind of Teflon spray, what you like to have. That's also everything like this is fine, but no grease. This is really what you should avoid. So there was also some other technology, what calls like the PTFE oil seals. The PTFE oil seals was also invented more or less like by the technology because the heavy duty applications, so the heavy duty engines, they were searching for, or more or less like saying something like this. It came up because trucks, they have the earlier steps to have a better emission-C. So it means like emission-C Euro 4, Euro 5, Euro 6. And based on them, they are also one step ahead to fit into the new emission-C standards, what it came up. So in this case, there was also one thing for emission-C is to reduce the fuel consumption, and to reduce the fuel consumption, there was the idea to reduce the frictions or the frictions on different kind of parts. And so they said, okay, if we can reduce the friction on a shaft against the oil seal, so we can also save fuel. So, and if you can save fuel in this kind of application, that's maybe a benefit. And this is one point what you can work on an engine. And in total, if you can save 0.3% of fuel for heavy duty engine application, that for that kind of engine, it's quite a lot with only changing an oil seal. And so they also took over this kind of technology in the passenger cars either. So in this kind of things, it's quite good, but this kind of technology also created some headaches, more or less like for the mechanics, because they had the knowledge about how they're mounting the classical oil seal, and they did this all in the same way with the PTFE, and all of them are failed. There's a reason for it, and I will explain you why there's a reason for it. But before we coming to these details, or to these facts, I will show you also here about this matrix that you see. The FPM material is resistance up to 250 degrees, doesn't matter what kind of oil you use for. And this is also the material as itself. So this PTFE, better known as Teflon, is highly heat resistant. It's a self-lubrication product. It's also from the minus temperatures are resistance against that. And it's the best material what you will find for any kind of application to reduce frictions. So the layout of this PTFE oil seal is also a little bit different in comparison for classical oil seal, because as you see, we have outside also a rubber shoulder. We have also a metal inside. That's okay. But here, this part here especially is separated from the other one, because this is our PTFE oil seal. And this comes in a shape. It's glued here against next to our elastomer material. It comes in a defined shape. And as you see, we have more contact points as in comparison with our classical oil seal. So here, for example, 5. Based on the design of this oil seal, we have more contact possibilities. The other thing what we're also missing is like a spring, because we have no more a spring what puts a pressure against our sealing spot. Nowadays we have only a drag lip, but we are laying on the shaft and no more pressing against the shaft. And this is also one of the things. This laying is reduced, or is also reducing a little bit of frictions, and also in the addition of the PTFE material, this is also reducing the frictions. That's the main thing. So, but now we're coming how you install this oil seal in a proper way, and what are the more or less like things what the mechanics did wrong in the past, and still, because for us a PTFE oil seal is still #1 of warranty claims what we have for A-ring. So in the beginning, as you see, I have here an oil seal. There's also coming with an housing and a protection tool, a sleeve inside. That's necessary because this PTFE oil seal is very sensitive about deformation, about any kind of marks. So you have to protect them also during the transport. So if you receive this and this is not stuck in an equal way inside, then I would not recommend to install an oil seal like this. Only if you see by yourself it's in perfect condition. Otherwise, you have to do the job again, and something is this what you don't want to do, because it's double the time, double oh, sorry, there's now my SAP system telling me something. It's double the time what you waste for the installation of an oil seal. So next step will be checking the shaft if it's in good condition. So then it's the first important thing is like put a protection sleeve over the shaft, because this PTFE oil seal lip is very sensitive. And the first thing what you see, don't use any kind of oil inside and outside of this PTFE oil seal. This is not recommended. It's not good to use that in this case. So it's really different as with the classical oil seals. Then put your oil seal equal over the shaft with your mounting tool. It's very important. And now it comes the point. What you see here, you have to wait 4 hours until you start up the engine. So now it comes to the question, why do you have to wait? Because if you check out this PTFE lip, this is a very stiff material, and the material as itself is a self-morphing material, so it morphs back into the shape as it was, but for morphing back into the shape, it takes time. So what we are doing here in that step, it's quite easy, because if you take a look on the design, it's going up. So we widen up a ring, and if you widen up a ring, so we want to do the diameter, the inner diameter bigger, that we can come over the shaft without any problems, without any contact, without any damage on the oil seal. And if we spread this out, then so we will widen up the oil seal. And if you put this into the end position, now it needs time that it comes back into the shape as it was. And coming back into the shape as it was takes time. And so we said the maximum is 4 hours. This is not all the oil seal needs 4 hours, but the maximum is 4 hours that you have to wait until you start up the engine, because high RPMs is something what you really, really should avoid. What is no problem if you put the oil seal in and you more or less like move the shaft by the hand, because you have to move it, whatever, that's not a problem. But please avoid to go with high RPMs in the beginning if the sealing lip is not in a good contact way to the shaft. This is really something what you should avoid, because if it's once a time starting with leaking, there's more or less no second possibility to clean it up and try it again. So you have to change it to a new oil seal. That's very important. So, and these two things, like using nut oil and waiting for 4 hours, is still a headache for all the mechanics outside in the world. Doesn't matter where, still we have the problems. They don't know it, or they know it or not. In the past, we had inside in our packings, we had this very small information with these pictograms, the same what you see here on the picture. Nowadays, it's a little bit different, because we do a printing on the cardboard, if you see it like this. So nowadays it's like here, the pictograms. So that's a benefit. If they put it out of the box, the new oil seal, then they will not throw the small paper away. They have the box, they're turning around and see, okay, I have something to take care about that. So this is the benefit. So yeah. This is the oil seal, PTFE, well known, and now the new oil seal without a spring, and the hybrid version between the classical simmering and the PTFE oil seal is nowadays this is like an OF ring, so it means like the ring is coming without a spring. What does it mean? If you check this layout of the ring, it looks like the same as a classical PTFE ring, but well, not but the more or less like the detail view is also of the cut view. We have also no spring. We have a track clip. We are laying on the shaft. We are not pressing against the shaft, but the material what we use is FPM. So outside FPM, inside FPM. This is what we know from our classical oil seals. That is a benefit. We have not a self-lubrication material, but we have a rubber material. And rubber material means like this is not so stiff as the PTFE. So it means like if we are bending this lip and putting this down, it comes back immediately. So we have not the waiting time. This is the main difference between the PTFE and the OF rings. So it means if you check out, this is the instruction manual about this. It's also not recommended to use any kind of oil during the installation because this oil seal is coming slightly oiled. So if you touch this, you can feel it. So that's not necessary to adding more oil on it. So in this case, you don't have to do it, but you have not to wait the 4 hours. And this kind of rings are nowadays used in more and more modern engines. So this is the benefit out of it. It's in a lot of BMWs. It's also in PSA engines inside. Also Renault is using this nowadays. So you will find this more and more everywhere. And they replace this also to PTFE rings. The reason also it is the FPM material, it's much more cheaper as the PTFE. And also the installation is less problem as we had before with the PTFE. And the benefit is also like we also have less frictions against the shaft because we have no more the spring. We have the same sealing technology. So in this case, this is the newest ring what you will find nowadays in modern engines. All right. Besides the OF ring, and OF is standing for ohne Feder from German. Sorry about that again. That's the reason without spring, OF. This is the declaration what you will also find here as an example as classical A. A means like we have a little bit rubber, B is metal. Then we have W, this is like a waviness here on top. The S is like the dust clip, and then we have the OF, so it means without a spring. So now you know really the descriptions, how it looks like, and what does it mean. So the oil seals, what you also know about with the sensor ring or with the sensor ring inside, also used as PTFE, is well known for VHG models like Volkswagen, Seat, Skoda, Audi. They're using this kind of technology. It's, I think, still well known. You need some special tools. Nowadays, they are no more so much expensive as they was some years ago. And I think nowadays this is no more so much special things, but also this is like a combination out of special tool and PTFE material is still the reason why also one of these rings is also claim #1 in our company, but it's more or less like 99% rejected because there are some problems of the guys in the workshop. They don't know how to install it. Some other very important information is besides the oil seals, it's also because if you have oil seals without housing, what is nowadays also more and more common, they have also some elastomer sealing lips outside. And this elastomer sealing lips, as you see here, they're doing the job by themselves. That means like this elastomer is putting against and needs the flexibility to work in any kind of temperature resistance and vibrations and so on. So they need space to work on it. And what it's not recommended, what you see here, to use any kind of silicon RTV to be on the safe side, to make a better sealing job, because in this case, you will not support them, you will work against them. This is like the point. Why? Because this lip needs flexibility to the right and to the left side. This is based on the design. And if you're covering this kind of space up with some material, which is you will not support them, you work against them. So there's some defined spots where it's recommended to use. This is underneath where the oil pan is, but also check about the quantity. This is quite too much where they used like here, because there's also high risk that something is going into the sealing line from our oil seal. This is also what you should avoid. So this is really a critical point. This is very important to mention to you, that also this kind of fact, you know. The other big question is all the time how you remove oil seals, because the removement of an oil seal, there's a lot of techniques outside in the world, let's say, from putting any kind of screw inside into the oil seal and then go with the plier and pull it out, or go with a screwdriver, whatever. So there's a lot of solutions, which is a classical way to remove oil seals. But in the end, oftentimes there's a problem that you maybe will destroy the shaft, or you will destroy the oil seal or the housing. To avoid all of the things, I found, and I will show you this, because it doesn't matter where in the world, I will show this in real to any kind of attendees for trainings. They do immediately a photo for it and said, I also want to have it, because it's so easy and so simple to use. And I'm also a fan out of it. That's the reason why I promote this. It's not from Ehring. I can only show you it like this, and this is like the tool. What it comes from Stahlmax. That's also a German company. It calls also XXL Automotive. This tool was invented by Volkswagen and was very expensive, but they also did a copy out of it. And why it's so simple? You have here in front, you have here a hook. So there are two sizes are available for small rings and for big rings. And you have a hook, and the hook is out of the line. So it's a little bit bended to the right side. And with this lip, and then you go with the hook behind the oil sealing lip. And with the opposite side, this is like what you see here, you go around of the housing. And the next step, what you have to do, it's quite easy. You have only to pull the handle to this side. So if you pull it out, then immediately you pull the oil seal out, and it's quite easy and simple. And you will dismount the oil seal with close to be no defects around of the oil seal. Quite easy and simple. So this tool really, you can use it everywhere. And if I show this in a real demonstration, and if we are lucky and I can come by the Dodge, then you will see this also in real, how we can remove an oil seal in under 1 second, without drilling holes and whatever, and destroying more or less like the shaft. This is really a clever tool. So only some hint from my side. So before, sometimes there's also some questions about requirements of the shafts. So this is also what I want to mention to you. Roughnesses, what it's recommended to have as a hardening, as a roughness on a shaft, but also what is a tolerance, what can be the tolerance of an oil seal, how many millimeters is more or less like possible to be in a more or less like in average, or more or less like, yeah, for an oil seal, what it can work on it. So the first is like the roughness, what we want to have for surface roughness. This is 1 to 4 micrometers. This is very less, so you will more or less like not see any kind of scratches on the surface. The RA is also 0.2 to 0.8 micrometers, is very less, and the maximum roughness is 6.3. So in the end, a very, very smooth surface, because we don't want to have any kind of mislining things on the oil shaft, on the shaft. So this is really important. And sometimes it also exists some hardness of the shaft. So it means like they get some adduction hardening spots around of a shaft, and that's also sometimes a risky thing. If you overhaul, or you will more or less like grind the shaft, then you will take this hardness away. This is a special thing, so maybe you have also to check about the shafts and the conrods, what it's necessary to fulfill, or if there are any kind of special induction hardnesses on the surfaces. So this is really something what you have to check before you're grinding any kind of surfaces of the shaft. So now it's a question. If you have questions, I see somebody put something in the chat.